Hello guys and welcome back to the channel. Today we will be going over a data structure called stack, and in this video we will be covering what is the definition of a stack. We'll go through some examples so that you can better understand how the application works with something easy and something you can remember, and then we'll go through the different operations you can perform on a stack. So push, pop, peek, and I'll actually be showing you a visual representation also about how these things work so that you can remember it better. And one of the more important things is also to understand how it's stored in the memory and how the memory management takes place. So we'll discuss that a little bit. And then we'll go through some examples of how this is practically used in applications today. And then finally, we'll cover the space and time complexity. So that should give you like a complete overview of what is a stack, and then we'll do the code implementation, so you should have a pretty good understanding of what a stack is by the end of this video. Let's get into it. So let's start with the definition. So stack is a linear data structure that follows the last in first out principle. Okay, let's break this down word by word. When we're talking about a linear data structure, you kind of want to imagine a stack as like a vertical column where you are going to be placing elements into it. So how can you understand this better? Think of like a very common example used is like a cookie jar. So if you have like a jar of cookies, and you're just putting one by one each cookie into that jar, then the last cookie you can actually take out from the jar is the one which is at the top. Like, you're not going to reach all the way to the bottom of the jar to pick up a cookie, right? You're going to take the one that's at the top of the jar. So another example is like a stack of books. So you have like a bunch of books, let's say, which are stacked up. Like, let's say you have like 15 books which are stacked up. In this case, let's assume that you can only take off the book from the top. I mean, with a lot of struggle and difficulty, you can probably take out books from the bottom as well. But let's say for this instance that you are only able to take off the uppermost book or the book at the top. The stack is kind of the same thing. But it follows the strict rule that you can only take out the elements from the top and you can only insert elements at the top. So that's why you kind of think of like a jar of cookies. It's the bottom is closed. You can't actually do anything with it. So that's what this means. It's a linear data structure that follows the last in first out principle. So what kind of things can you do with a stack? So first thing is, let's go to our visual representation here. So here, like I said, imagine like a vertical column. So let's say that this is our jar or this is our stack, which is shown in a vertical fashion. And here are the different elements or items that I have. I just have 3 blocks, 1, 2, and 3. And let's say I want to put these into our stack now. So putting an element into a stack is called the push operation. So let's go back to our notes. Pushing is adding an item to the top or inserting an item into the stack from the top. So let me take my first element, which is 1, and let me push this into the stack. So now you can see the first element that I have selected, which is item number 1, has been pushed into the stack from the top. Now it's at the bottom because now I just pushed it in and it went all the way to the bottom. Now let's say I pick up the second element, item number 2. Now I take this item and I'm pushing this into the stack as well. And now you can see 2 is layered on top of 1, which means that the second last element which I have inserted into the stack, number 2, is being pushed on top of 1. And now 1 is at the bottom, 2 is on the top. Now let's take our third element, number 3. And I'm taking number 3 and I am pushing it onto the top of the stack. So what have you observed here? I pushed the items in the order of 1, 2, 3, but now 3 is at the top, 2 is in the middle, and 1 is at the bottom. So this brings us back to that first principle that we were talking about, last in, first out. So the last element that I have added into my stack, which is number 3, is actually the first element that I can take out now. Can I take out 1 from here? No, because 1 is pretty much in a closed location at the bottom. So I can't actually take out 1 from there. So the last element which I have pushed, which is number 3, is the first element I can take out. So that is where the last in first out principle comes from. So now we learned what it means to push or insert an element from the top. So what does it mean to remove an item? Removing an item is called pop when it comes to a stack. So if I'm removing an item from the top, I am popping elements from the stack. Let's take a look at that. So I'll go back to my stack here and I'll select my item number 3 and let me pop it. So the last element that I have inserted is now the first element which has come out, and then the second element that I have access to is number 2 here. So let me pop this from the stack as well. And finally, the initial element which I have pushed in the beginning, 1, which is all the way at the bottom. Now let me pop this element as well. So now you can see that I've popped out all the elements from the stack. And now you can see that I've popped them out in a reverse order, basically. That is what popping means. Pretty simple, straightforward. Now let's talk about what it means to peek. So peek means, like, think of like, hide and seek or something. Peeking means like you want to take a peek. You want to look at what is there, right? So when you're peeking an element in a stack, you basically want to see what element is the one that you can access. So right now, I took out all the elements from the stack, but let's say I just have them in the stack. Let's say I just have number 2 in the stack here. So if I peek into the stack right now, I'll see that the uppermost element or the topmost element or the element which I have access to right now is 2. So if I peek in a stack, I'll have access to number 2. Now let's say I take item number 1 and I push this into the stack as well. Now can you tell me which element I can peek at in the stack? Yep, it's element number 1 or item number 1. And if I push 3 also into the stack, now you can see that the element that I can peek at is number 3. So that is what it means to peek. And finally, isEmpty is a common method which we use. And let me tell you a little bit more about this while we're implementing the code, why it's important to use this method. Because we come across something called like a stack underflow condition. So to make sure that doesn't happen, we use a isEmpty function. And as you can tell by the name, this means, is the stack empty or not? Does it have any items or not? That's all this method will check. So right now, is the stack empty? No. There is 3 elements or 3 items in the stack. So the size of the stack is 3. If I just remove all my elements from the stack, or pop, as I should say, I say pop 3, I pop 1, and I pop 2. Now, can you tell me if the stack is empty or if it's full? Now it's empty, right? So that is the empty function in a stack. Okay. So before we talk about the memory management and things like that, let's actually start implementing these in the code and discussing them in more detail as we go. Okay, let's start with creating a blueprint. So we want to create a proper template for our data structure. So let me call it as a class, and I'll name my class as stack. Okay. And now I'm going to define the constructor. Oops. And I will call this stack. And in my implementation in this program, we will be building our stack off of an array data structure, or in Python it's called a list. So we will be building off of that data structure to create this stack. So the first method, let's implement pushing an item. So we'll call it push item. We pass in self again since we're trying to access elements of this class, in this case the stack that we have defined earlier. And let's pass in an item as the parameter which we will be sending in once we call our functions from the main method. So I've sent in the parameter item, and now let me append the item to the stack. So here I'll say self.stack.append item, and this will push the item to the stack. Now let's say I want to add multiple items to the stack, right? So I will say push items, pass in my self argument, and I'll pass in a list of items as a parameter, and here I'll say I'll actually iterate through this items parameter. So I'll say for each item in items, stack dot append the item. Okay, and let's actually test this out, and to test it out, let's also just quickly create a method to print the stack. So I'll call it print stack, and I'll pass in the self argument, and I can just use the built-in function print and print the stack. Okay, so we've created a method to push a single item, push multiple items, and print the stack. So now let's actually create our main method. So I do that in Python this way. And main is basically where the Python interpreter starts reading the program from. And here I'm going to create an instance of the class or an object, and I'll call it object S1. Just create an instance of the class, and I'll use S1, and I'll call our methods which belong to this class. So let me say push item, and let me push 4, and let me also push what's a good number, 10. So that is when I'm pushing a single item. And now let's also call our method to push multiple items at once. So let me say push items 2, 3, 6. And let's finally call our method to print the stack. So, oh, I actually forgot to put our parentheses there, no problem. And here I am going to print the stack. Okay, so let's run this program. Okay, cool. So our output, as you can see, let me make it a little bigger. First we pushed in 4, then we pushed in 10, then we pushed in 2, 3 and 6 at once, and that is our output. So first operation done. We've pushed all the elements into our stack. Next, let's create our method to pop an element from the stack. Okay, let's create a method here. This is pretty simple actually. I'll call it pop item. And Python has its own built-in pop method to use for stacks, which will remove the uppermost element from the stack. So all I have to do is self.stack.pop. So what this does is, it'll pop the uppermost element from the stack, and I can go ahead and implement it right here. So now we've printed the stack up till here where we've pushed the items. So now let me say pop, and let me print the stack again. Run this program. Oh, I actually did not put the right method name. That's okay. Yep. So now you can see the last element which was pushed into the stack, which is 6, is now the element which is being popped out. Don't forget the rule. Last in, first out. The last element which is added in is the first element which gets popped out. So that is our pop item method. Cool, we are done with pop. Next, let's go on to peek. This is also very easy to implement. Let's call it peek. Pass in our self, and Python actually allows you to index from the -1th element or the last element in the stack, the last thing which has been added into the stack. And all I need to do for that is print the stack of -1th index. So let's see what happens when I do that. I'll call the method and I don't need to pass in anything. I'll run the program. So now you can see that it outputted it gave an output of 3, which means that that was the last element which was pushed into the stack. So that when I peek, when I look at the top, like, hey, who's there, what are you, I know that it's number 3. And then our final method is empty. This is also pretty self-explanatory. So we're just checking if the stack is empty or not. And I'm actually going to use this method to modify one of our previous methods so that we don't hit an error. And I'll show you what that is. So let me define this method. Define is empty. And all I need to say is if the stack, or if the length of the stack is 0, then that is true, right? Otherwise, it's false. And I don't even have to put an else condition here. I can just make my default as returning false. And so what I'm trying to say here is, if the stack is empty, it will return true. If it's not, it will return false. So if I, for example, if I call this method, run this, I'm actually not printing anything in the method, so let me just print it here and run. And so now you can see that it gave me false. Why? Because there are a bunch of items in the stack. So is it empty? No, it's not empty. So that's why it gave me false. Let's say now, here is the interesting thing. Let's remove this pop item for a second and let me actually make it an empty stack. You know, like I didn't push any elements into the stack. Right now it's empty. And let's see what this program does. Well, it gave me an error because we'll fix that actually right now. But if I show you right here, I created an object and I'm printing the stack without pushing any elements. So it's empty. And is it empty? Yes, true, it's empty. So now you kind of got a glimpse of an error message earlier when we had the peek function here, right? It's an error with the peek function. And I'll tell you what, it will be an error with the pop item function also. Why? Why is this happening? Well, think of it this way. Let's go back to our visuals here. If there's no items in the stack, right? Like if you look right now, is there any item in the stack? No, it's empty. So I'm asking you to pop an item from the stack or remove an item from the stack, or I'm asking you to peek at what item is at the topmost part of the stack. Is there anything here? No, it's empty. So that's why it's throwing an error. This error is called the stack underflow. So I'm sure you know what the word overflow means. Overflow means you just have too many things in the stack. Underflow means you have nothing in the stack. So you can't pop anything, you can't push anything. Oh, you can't, sorry, not push. You can't peek anything. So to make sure that you don't hit this error, we actually have to check whether the stack is empty or not before trying to pop or peek from the stack. So if I go back here, push items, pop item, there it is. So before I pop an item from the stack, I actually want to make sure that I do it this way. Right? So here I'm saying if the stack is empty, is false, then pop and return. Otherwise, print that the stack is empty and I can't do anything about it. So when I run this program again, I guess I gave the wrong method name here. I'll just change the method name here. Hopefully that fixes it. Yep. So now it prints the message stack is empty. So it can't pop, right? And I will just add that too. So now I'm saying the stack is empty and I can't pop. Now same goes for the peek function. You want to implement the same thing for peek. So I'll just copy it, I'll copy, and instead of saying pop, I will say print the negative 1th element. Otherwise, print that I can't peek. Run this program. Actually want to call the right method, right? This time I want to call peek. Run this. So stack is empty, can't peek. So that is how you implement the push, pop, peek is empty methods in Python for a stack. Next, let's quickly talk about the memory management. So in Python, the memory for a stack, since we are building it off of an array data structure, it is stored in a contiguous memory system. What does that mean? That means that all the elements are stored next to each other in memory, and it's also a dynamically resizable structure, which means that the more elements you add, the bigger the size of the stack becomes, and the more memory is allocated for it. And the more items you pop, it'll automatically resize to reduce or remove those memory spaces and make it smaller. And that is a basic understanding of the memory, and I'm not going to get too deep into it. And so we'll just go to the next part, which is what are some practical uses where we are using the stack for, right? So you can undo and redo in text editors, right? Like right now, if I just do Control C and Control Y, I can undo and redo things. How is that happening? That's actually happening because each of your actions is stored in a stack. So what happens is every time I type something, that action gets pushed to the bottom of the stack and it continues. And when I try to undo something, it picks up the last action that I performed and removes it or undoes that method from the top. And then it goes to the second last thing and then the third last thing, and then it undoes all those actions in that way. So I'm sure you've done undo redo many times, and like when you're writing like an essay or in your code or things like that. So that actually uses the stack. And I also want to talk about this other thing where a lot of code editors, they actually check whether you have closed and have enough of matching parentheses. Like right here, let's say I didn't close this method. Like right now, I have 2 open parentheses and no closed ones. How is it detecting that there's an error here? Right? So actually each parenthesis is fixed or it's pushed into a stack, and then as your characters are adding on in the string, it'll push in the second parenthesis and say that okay, the second one is closed, the innermost parentheses are closed, and it'll keep adding the characters until the outermost parentheses are closed. And once it finds that each bracket has its matching pair, then you can say that yeah, all the parentheses have matched, or hey, no, all the parentheses have not matched, hence that little red error line here. Okay, so that is kind of a pretty practical usage that we use every day for stacks. And let's quickly discuss the time and space complexity. So space complexity, since we built this off of an array, we are using an array to build our stack. So this is going to be O of n, where n is the number of items that we are pushing into the stack. And time complexity, the reason why stack is such an efficient data structure, since we are just pushing and popping elements, we are only utilizing one element to push and pop and peek. So since we are doing that, this is going to be a constant method. This is going to be a constant operation. So you will be doing this in O of 1 fashion. So that kind of gives you a pretty like whole rounded explanation of what is a stack and how to implement it in Python. And I hope this video has helped you understand it better. I'll leave links to the code and these notes in my GitHub repository in the link below so that you can access it. And yeah, let me know if you have any questions in the comments down below. And thank you for watching this video. And in the next video, we will be talking about queues. All right, thanks for watching.